Hello everyone, I am Omkar Upadhyay and this is my project title Pixel Dialogue an agent-driven multimodal chatbot for image-based interaction. In this presentation, I will explain the motivation behind the project, the architecture and model used, the methodology, and demonstrate key features like captioning, object detection, OCR, and image generation. I will also share the challenges I faced and the future enhancement plan. Most traditional chatbots operates purely on text input. While they are effective for conversational tasks, they completely fail when user provide image. In the real world scenarios, images are everywhere. Screenshots, documents, product photos, signs, and daily life pictures. A chatbot that can't understand image is limited in scope and can't support many practical tasks. So the motivation for this project was to build a system that bridges this gap by integrating vision capabilities into a conversational agent. The objective of this project was straightforward but challenging. Create a chatbot that can understand an image just like it understands text. To achieve this, the system should be able to perform image captioning, detect objects, extract text from the image, and generate new images based on prompts, all within a single unified interface. And importantly, the chatbot should decide automatically which tool to use based on what the user asks. This diagram shows the structure of the system. The workflow begins with the user uploading an image. The image path and the user question are passed to the LLM agent. The agent interprets the query, identifies the task, whether it is captioning, detection, OCR, or generation, and then calls the correct tool. Once the tools process the image, its output is passed back to the agent, which formats the final response and deliver it to the user via Streamlit interface. This architecture makes the system modular and scalable. I used a combination of specialized models for different tasks. BLIP large is used for image captioning because it performs well in zero-shot captioning tasks. For object detection, I integrate YOLO, which provides accurate labels and bounding boxes with high speed. EasyOCR handles text extraction, making it useful for document and syntax. Image generation is handled by stable diffusion. Finally, the agent itself is powered by LLaMA-based model, which interprets user intent and select the appropriate tool using LangChain. All of this is wrapped inside a Streamlit interface for easy user interaction. The methodology revolves around agent-based orchestration. When a user sends a query, the LLM reads it and determines what the user wants. There is no manual routing. The agent itself chooses the correct tool. For example, if user asks describe this image, the agent triggers the captioning tool. If the user asks what objects do you see, the detection tool is triggered. For text like extract the text, the OCR tool run. This dynamic routing makes the chatbot intelligent rather than rule-based, and it allows easy addition of new capabilities in the future. In this project, Python is used as the main programming language. LangChain manages tool invocation, memory, and message passing to facilitate agent-based workflows. Streamlit is used for interactive frontend. Integration of vision models like BLIP, YOLO, EasyOCR, and stable diffusion enhances image processing with GPU acceleration. Across all tasks, the system performs as expected. It produces meaningful captions, accurate object detections, readable OCR outputs, and visually coherent generated images. The key takeaways is that all these tasks are handled seamlessly within one unified agent. I faced several implementation challenges. Choosing the correct LLM was difficult because some models did not support tool users properly. API rate limits caused interruption during early testing, so I had to disable streaming. Another major issue was passing image paths reliably between tools inside LangChain. Handling tool outputs, especially generated image paths, and managing temporary files was another challenges to prevent conflicts. But solving each of these contributed to a stronger understanding of multimodal pipeline. In conclusion, Pixel Dialogues demonstrates how agent-based architecture can enable true multimodal reasoning. By combining different models under one coordinating agent, the system becomes flexible, modular, and capable of handling complex visual tasks. The project successfully integrates vision and language in practical, usable form. In the future, I plan to expand the system with voice to text and text to speech features, reduce latency with caching and optimization, and enabling multi-image comparison. I also want to expand the system to video analysis such as identifying main characters and tracking emotions throughout the clip. Additionally, supporting multiple PDFs, cloud deployment, and showing token users are part of the roadmap. Thank you for watching this presentation. All links including the GitHub repo and the Medium article are provided for more details. Feel free to reach out if you have any question.